Hi everyone, welcome to the first video in our week 5 series. And this week we're talking about hypothesis testing. This is a continuation of the discussion we started last week on inferential statistics. So last week we learned about estimation and confidence intervals, which are a form of interval estimate. With confidence intervals, we used sample data to estimate an unknown population parameter. This week, what we're doing is sort of the opposite of what we did last week. This week, we're doing something called hypothesis testing. With hypothesis testing, there's already a claim about the population parameter. So we have a value for the population parameter. We want to test the validity of that value using sample data. So we're selecting a sample from a population and saying, does this sample match what we think the population value is? So in this process, we will be given a population parameter and we will compare it to sample data. And we're going to do that for two different parameters. We're going to do that for means and proportions, just like we did with confidence intervals. Hypothesis testing consists of two contradictory hypotheses about a parameter, a decision based on sample data, and a conclusion. To perform a hypothesis test as statisticians out in the real world, we need to set up the hypotheses that we want to test. We collect sample data to verify the validity of one of those hypotheses. As a student in statistics, this step's going to be given to you. We then determine the appropriate distribution to use for the test. And so far we've looked at two. We've looked at the standard normal distribution and the student t distribution. And the decisions that we made last week for confidence intervals when deciding which distribution to use, the same criteria is going to be used this week for hypothesis testing. So there is consistency across inferential statistics about deciding, do we use Z or do we use T? Once we've decided the appropriate distribution, we analyze that sample data by performing calculations. We'll calculate a Z-score or a T-score based on that sample data. And then we'll make a decision based on those calculations and write a meaningful conclusion. There are two methods for performing the hypothesis testing. Both of them follow this general outline. We'll talk about both of these methods in future videos, and you will be free to choose whichever method you are more comfortable with. But the underlying principle for both methods is the same, and that's what we're going to be talking about in this video. So first, we need to talk about that very first step in the list on that last slide. We have to write out our hypotheses. What are we testing? So to begin our hypothesis test, we have to write out our null and alternative hypotheses. These are two statements about a population parameter that are contradictory. They're opposite. The null hypothesis is a statement about the population that either is believed to be true, we're assuming that it's true, or we're using it to put forth an argument unless it can be shown to be incorrect beyond a statistically reasonable doubt. In this class, the null hypothesis should always be an equality. We're always going to use an equal sign, though you will see, particularly in the textbook, sometimes they'll use a less than or equal or a greater than or equal. It is important that the null hypothesis is the hypothesis with the equality. The alternative hypothesis is then the claim about the population that contradicts the null. This statement always contains an inequality. So the opposite of equals is not equals. The opposite of less than or equal to is greater than. The opposite of greater than or equal to is less. The upside to the method that I and many statisticians use is that if you always use equal sign for the null hypothesis, you don't really have to think too hard here, and the wording in the question should tell you what to do with the alternative. We're going to see lots of examples in the coming videos, so if it doesn't quite make sense yet, don't panic. We will revisit this repeatedly throughout the videos this week. So we're going to use these contradictory hypotheses. We're going to pull sample data and then decide, is there enough evidence to reject that null hypothesis, that assumption that we're believing that proportion or that mean is true. After you've determined which hypothesis the sample supports, you make a decision. And there are two possible decisions: reject the null hypothesis if the sample favors the alternative, or do not reject the null hypothesis if the sample information is insufficient to reject it. It is important to notice that both of those decisions in bold are in terms of the null hypothesis. So our decision is always looking at that statement of equality that we assume to be true. Is the sample different enough to reject that null? Or is the sample too close to that assumed value and we can't reject the null? We don't want to discuss the alternative until our very last step for conclusion. A couple signals. So if your null is equal, which is my default, you will see either not equal, less than, or greater than as your alternative. If your null is greater than or equal to, your alternative should be less than. If your null is less than or equal to, your alternative should be greater than. I'm going to be operating solely in that solely in that first row. So when in doubt, use this as the null. But your book is going to use that second and third row as well. And using that is not wrong. The reason that your null hypothesis symbol is less important is that when we're making decisions and testing our sample information, we're exclusively focused on the symbol in our alternative hypothesis. And that's going to determine the type of test we run. So it's okay to always treat the null as equal because it's the alternative that determines our test. So a couple examples. We want to test whether the mean GPA of students in American colleges is different from 2.0 out of 4.0. State the null and alternative hypotheses. So reading that statement, the first word that pops out to me is different from. Is the GPA different from 2.0? And I know that different means not equal to. Could be less than, could be greater than. That not equal to, that's an inequality. That's going to go in my alternative. So my alternative is the mean is different from 2.0, not equal to 2.0, which then means that my null must be the equality statement. The mean is equal to 2.0. Let's do that same process really quick with the next example. It says we want to test if college students take less than 5 years to graduate from college on the average. State the null and alternative hypotheses. So the first relational statement that pops out to me is the less than 5 years. Less than does not have an equality part to it. That's an alternative hypothesis statement. So I know my alternative should be the mean is less than 5. For the null, I'm going to assume it's always an equal sign. Mean is equal to 5. your book will probably write the opposite of less than, which is greater than or equal to. Either pair is correct. Notice that the alternatives match, and that's the important part. Okay, so let's talk about outcomes and possible errors when you run a hypothesis test. There are 4 possible outcomes of a hypothesis test. We make the decision to not reject the null, and the null is actually true. So we made the correct decision. The assumption is true, and we did not reject it. It's also possible that, ooh, there's a typo there. Let me fix that while I'm talking. We make the decision to reject H naught when H naught is true. Just paste that there. Thank you for your patience. So we know that assumption is true, but the sample data we collected tells us we should reject it. And in that case, we make an incorrect decision, and that's called a type 1 error. On the other side, that null value that we assume is true could actually be false, and we fail to reject it. So we should and we don't. In that case, that's a type 2 error. So a type 1 error is rejecting when we shouldn't. A type 2 error is failing to reject when we should. The last is another correct decision, the decision to reject the null when the null is false. And that's correct, we should do that. The probability of that happening, the probability of rejecting the null when the null is in fact false, is something called the power of the hypothesis test. We're not really going to come back to that. It's more of a recent discussion in statistics. It didn't come up when I taught the class, and it's not something vital to know. But if you see that in a text, that's what it's talking about. What is the likelihood that you reject when you're supposed to reject? And that likelihood is called the power of the test. So we've organized our errors in this table. H is true, and we don't reject. That's correct outcome. H is true, and we do reject. That's a type 1 error. If H naught is false and we fail to reject, that's a type 2 error. If H naught is false and we do reject, that's a correct outcome. Each of those 2 errors, type 1 and type 2, occurs with a particular probability. Alpha is the probability of a type 1 error occurring, meaning the null is true and we reject it. This new Greek letter, beta, is the probability of a type 2 error occurring. So the null is false and we fail to reject. Remember that that is related to the power of the test. Alpha and beta should be as small as possible because those are the probabilities of the errors. We don't want errors happening. 1 minus beta is the power of the test. That's this correct outcome here in the bottom where the null is false and we correctly reject it, which is the complement to a type 2 error. We want that as close to 1 as possible. So we want this correct outcome to be as likely as possible. One way to increase the probability of that correct outcome is by increasing your sample size. We know that our larger samples tend to be more reflective of the population pulling from and will be less likely to make incorrect decisions based on that sample data. The upside is moving forward. We're really only concerned with alpha, the probability of that type 1 error when we're making our hypothesis tests, when we're running that process. So our next video, we're going to go through one of the 2 methods of how to actually carry out a hypothesis test. We're going to start with the traditional method. This is the method that I learned how to do when we didn't have calculators handy. And then the video after that will talk about a computer method called the p-value method. If you have any questions, feel free to contact me. I've got my email open in front of me, and I've got office hours on Tuesday, Thursday, and Saturday. Check Canvas for the updated office hour schedule. I hope you guys have a good week, and I'll see you in the next video.